right. So for these first examples, you will need to have out your completed trig table. And so when we have these nested functions, so remember that both this is inverse cosine because it's got the -1, and this is sine. So both sine and inverse cosine are functions. So we need to work from the inside out. Okay, so first I evaluate inverse cosine of 1/2, which is pi over 3. So this becomes sine of pi over 3. And sine of pi over 3 using your table is the square root of 3 over 2. So the square root of 3 over 2 is the answer. Okay? Again, cosine is a function and inverse tangent is a function. So I start on the inside and evaluate inverse tangent of -1. So that's going to give me minus pi over 4. And so now I'm going to evaluate the cosine of minus pi over 4, which is in the fourth quadrant. So cosine is positive in the fourth quadrant, 1 over the square root of 2. Again, from the inside out, sine inverse of square root of 3 over 2 is pi over 3. So cosecant of pi over 3 is 2 over the square root of 3. I did that using the trig table. So I only looked at one thing at a time and answered each part. So continuing on. Oh, that's a mistake. What's that supposed to be? Okay, that's so inverse secant of minus square root of 2. So we find minus square root of 2 in the secant row, and it has to be in the black box. And so that happens at 3 pi over 4. And so now we evaluate tangent of 3 pi over 4. And we see that that is in quadrant 1, 2, sorry, that's quadrant 2, so it's going to be negative. Now we look up cosecant of -1, so, or cosecant of +1, so we go to the cosecant row, and we look for 1, and we see that that happens at pi over 2. So we get cotangent of pi over 2, and looking in our table, we see cotangent of pi over 2 is 0. All right, now we go to this one. Inverse tangent of minus square root of 3. And that happens at minus pi over 3. And then cotangent of minus pi over 3 is minus 1 over the square root of 3. All right, now we look up inverse cotangent of minus 1 over the square root of 3. Now, cotangent, inverse cotangent is defined in the first and second quadrants. So this is defined in the second quadrant at 2 pi over 3, I hope, because I don't actually have my trig table. And so now I'm going to look at tangent of 2 pi over 3, and that gives me minus square root of 3. So we have to look, depending on whether we're using, so remember that inverse tangent and cotangent, inverse cotangent, are defined in different quadrants for the negatives. Okay, now we're going to evaluate the following. These 3/5 is not in the table, so we can't use the table to evaluate these. But remembering that inverse sine, the input is opposite over hypotenuse and the output is an angle. So what we have is the angle is equal to inverse sine of 3/5. So if I take sine of both sides, now I'm applying a function. I'm not multiplying both sides by sine. I'm taking each side of the function and evaluating it, applying a function of sine. So this is going to stay inverse of alpha, or sine alpha. Over here, I have a function. Remember in the last recording, if you had a function and its inverse, you just got back x. So that's what we have here, a function and its inverse. So we just get back x. And so what I have is sine alpha equals 3/5. And sine is equal to opposite over hypotenuse. So this is a 3, 4, 5 triangle. So if here's alpha, and so the opposite side is 3, and the hypotenuse is 5. We can find the adjacent side is 4, and so what I'm evaluating is cosine. This becomes cosine alpha, which is adjacent over hypotenuse, 4/5. Okay, I'm going to take this problem to the next page so that we can work on it with more room. So we have cosine of inverse tangent of 9/11. Okay, so the input for an inverse tangent is opposite over adjacent, and the output is an angle. So I put in sides and I get out an angle. That's the way inverse trig functions work. So what I really have here, I'm going to call this cosine alpha, where alpha is inverse tangent of 9/11. Now I'm going to apply tangent to both sides. So I'm not multiplying both sides by tangent. I am taking each side and applying the tangent function. And so just like before, we have a function and its inverse. And since, if you remember from last week, the last recording, whenever the regular trig function's on the outside, it always just crosses off. It's when the inverse function is on the outside that we have to worry about quadrants and things like that. So we have tangent alpha equals 9/11, which is opposite over adjacent. So what that amounts to is having a triangle with an angle alpha, where the opposite side is 9 and the adjacent side is 11. Now, cosine alpha is adjacent over hypotenuse. So adjacent side is 11. See, adjacent. Now I need to find the hypotenuse. So the hypotenuse is 11 squared plus 9 squared, and take the square root. And that comes out to be the square root of 202. And so that is my exact answer, 11 over the square root of 202. So I'm going to write this. We don't have enough room with what I wrote on there. So this is tangent of inverse sine of 41 over 65. Okay, so again, what goes into an inverse sine function is opposite over hypotenuse. And what comes out is an angle. So we can rewrite this as tangent alpha, which, by the way, is opposite over adjacent. So I need to find opposite over adjacent. I have opposite and hypotenuse. So opposite is 41, and now I need to figure out adjacent. So I can keep drawing the triangle, but I'm comfortable with saying yeah, I guess I'm going to go ahead and draw the triangle. Okay, so here's my angle alpha. Opposite is 41, and hypotenuse is 65. So here's my adjacent side, and it's going to be the square root of 65 squared minus 41 squared. So that's kind of big. I'm going to have to get out my calculator. Maybe. All right, so let's clear. There we go. Okay. So 65 squared minus 41 squared is 2544. I doubt that that's going to be a whole number, and I'm not going to simplify the rational or the radical. So we'll just leave it at square root of 5544. So that's my adjacent side. And that's the answer. Okay. Number 4. Cotangent of tangent inverse of 5/16. So what goes into an inverse tangent is opposite over adjacent, and what comes out of an inverse tan function is alpha. So we can rewrite this as cotangent of alpha, which, by the way, is adjacent over opposite. Now, how much calculation am I going to have to do? Let's see. So tangent, alpha equals tangent inverse of 5/16. I'm going to apply tangent to both sides. And what happens, the tangent and the inverse tangent cancel out on the left or the right, so I get tangent alpha equals 5/16, which is opposite over adjacent. And what I need is adjacent over opposite, so I take this fraction and I flip it. There we go. I'm going to do a few more. I'm going to do some with negatives. So we have sine of inverse tangent of -7/3. What goes into a tangent function is opposite over adjacent, and what comes out is an angle. So this is sine alpha, which is opposite over hypotenuse. Now I know my opposite is going to be -7, because my hypotenuse is always positive. Inverse tangent, we're in quadrant 4 here, so remember this angle, because that's where inverse tangent's negative. And so this alpha sine's also going to be negative because we are in quadrant 4. So now I need to find the hypotenuse. So if I have opposite and adjacent, so opposite is 7 and adjacent's 3. So 49, 7 squared plus 3 squared is the square root of 53. 58. And that is my answer. Last one, cosine of inverse sine of -4/15. So remember, what goes into an inverse sine is opposite over hypotenuse, and what comes out is an angle. So this becomes cosine alpha. Now, this is negative, so inverse sine is defined for quadrants 1 and 4, and in quadrant 1 we get positive, so negatives happen in quadrant 4. Alpha is in quadrant 4, and cosine is positive in quadrant 4. So my answer is going to be positive. Okay, and cosine is adjacent over hypotenuse. Now I know what hypotenuse is. Hypotenuse is 15. What I need to figure out is what the adjacent is. I don't worry about negatives. Here's alpha, here's 4, here's 15. So I get 225 minus 16, which is 209. So that's my adjacent. So my answer is the square root of 209 divided by 15. Okay, the last little set of examples. Okay, evaluate the following with the calculator. Cosecant, inverse cosecant of 5. Well, if you go looking around on the calculator, you're not going to find inverse cosecant, unless they added it to calculate more recently than the calculator that I have. So we're going to have to do the same kind of thing that we were just doing. Okay, so you put in to a cosecant function, an inverse cosecant function, hypotenuse over opposite. And what you get out is an angle. So if I apply cosecant to both sides, what happens is it cancels out over here, and I get cosecant alpha equals 5, which is hypotenuse over opposite. Now, a button on my calculator that I do have is inverse sine. So if I can somehow turn this cosecant, inverse cosecant, into an inverse sine, I'll be good. Now, if cosecant is 5, and that's hypotenuse over opposite, then sine alpha is going to be the reciprocal of that. And now solving for alpha, because my original equation, remember, is cosecant inverse of 5 equals alpha. So now if I solve this for alpha by taking the inverse sine of both sides, what I get is alpha is equal to inverse sine of 1/5. So now, going to my calculator, let's look at the mode, which probably I'm in radians, so that's fine. So inverse sine of 1/5. 0.2014. So that's the answer, 0.2014. And that's in radians. So it's an angle measure in radians. If your calculator is set in degrees, then it's going to be a degrees. Okay, cosecant. Same problem. It's not defined. It's not a function defined on our calculator. So what goes into an inverse secant function is hypotenuse over adjacent, and what comes out is an angle. So if I take the secant of both sides, I get secant of alpha equals minus 5/3, which is hypotenuse over adjacent. Now, I do know what the inverse of cosine is. I have that button on my calculator. So I'm going to change this from secant alpha into cosine alpha, and what happens is I flip the reciprocal. I flip the solution. The minus 5/3 becomes minus 3/5, and now I take the inverse cosine of both sides, and that's equal to alpha. So secant, inverse secant of minus 5/3 is the same as inverse cosine of minus 3/5. And the output's going to be an angle measure. So I go back to my calculator. And I inverse cosine of minus 3/5. (2.2143). So that's an angle in quadrant 2. That's between pi over 2 and pi. So 2.2143. And that's my answer. And it's in radians because it's an angle measure. Okay, the next two are cotangents. Now cotangent has something funky that happens when it's negative, but let's look at the positive version. When the inside's positive. So what goes into cotangent is adjacent over opposite, and what comes out is an angle. Now if I take this and take the cotangent of both sides, I get cotangent alpha equals 7/3, which is adjacent over opposite, and I can turn it into a tangent. So tangent alpha is 3/7. So alpha can be written as inverse tangent of 3/7. So go to my calculator, inverse tangent of 3/7. .4049. And that's in radians, and that's the answer. Okay, cotangent when it's negative. So this angle, inverse cotangent is defined for quadrants 1 and 2. Alpha has to be between 0 and pi. Since it's negative, this is negative, we're going to be in quadrant 2. All right, so we take the cotangent of both sides, and we get cotangent alpha equals minus 5/9, which is adjacent over opposite. Now my tangent, when I take tangent alpha, that's going to be the reciprocal, minus 9/5. So alpha is, and I'm going to call this alpha hat, because when I take the inverse of both sides of this, I'm not going to get alpha. I'm going to get something that's in quadrant 4, okay, which is not in quadrant 2. I'm going to get something that's between, when I use inverse tangent, I get something that's between minus pi over 2 and pi over 2, not something between 0 and pi. So I'm going to go to my calculator, and I'm going to do inverse tangent of minus (9/5) and I get minus 1.0637. Okay, this is a third quadrant or fourth quadrant reference angle, or a fourth quadrant angle. I want something in the second quadrant. So I'm going to take this and add pi, and I'll show you why that is in a minute. But so I take it and add pi, and I get 2.0779. So my answer is 2.0779. Now why did I add pi? So I came out with this negative angle. And I called it alpha hat. Well, it turns out, well, alpha hat. Now, its reference angle is the same here, okay? So as I extend this line backwards through the origin, I get this vertical angle between the x-axis and the angle line. And so the answer, what I'm actually looking for, is this alpha right here. And I don't get alpha when I use inverse tangent. I get this alpha hat. So to find alpha, look, if I take alpha hat in absolute values plus alpha, I'm going to get 180, or pi. See, here's alpha, and then there's alpha hat. So these two together form a straight angle. Whether I look here or here, I get a straight angle. So this one's negative. If I add pi to it, that's like in absolute values, that's going to equal pi. So if I subtract that from both sides, but alpha hat is negative, so I don't have to worry about absolute values. I just have to take the answer and add pi over 2 because it's already negative. Or add pi, sorry, not pi over 2, add pi, and that's how I get the answer when cotangent's negative.